Hello, good morning friends. In last video lecture we have to discuss about the number system and the conversion of the number system, either binary to hexadecimal, hexadecimal to binary, binary to decimal, decimal to octal, like that, right? Now in this video lecture we have to discuss about the Carnot map method, otherwise it is also known as a K-map, right? So first one, what is the need of K-map? K-map is nothing but whenever any mathematical function is given, by using a K-map we can simplify the mathematical function. So dear students, we know about that any function can be represented in two different ways. For example, either function can be represented like that, a dot b plus b dot c plus c dot a, and the second way, a plus b multiply b plus c multiply c a bar plus c, like that. So this is a two different way to represent the any mathematical functions. So in this way, first case, here we have to consider the multiplications of every variables. Multiplication, that means it is known as a product. And then the resultant of this product, we have to take the addition of this every product, and the product, it is also known as a sum, right? So this is a multiplication is known as a product. So this function is known as a sum of product. In short, it is known as a SOP form. In second case, here we have to take the first addition can be represented as a sum, and then the result of this addition we have to take the multiplication means it is known as a product, right? So this is a different form of the K-map structure, and first we take the sum, and every sum is represented in terms of the product, so it is known as a product of sum, otherwise it is known as a POS form of K-map, right? So this is the two different form of the Carnot map method. Now each and every terms of SOP forms, each and every terms means a dot b, b dot c and c dot a, this is known as a mean term, while in case of the POS, each and every term of product and sum means it is a plus b, b plus c is known as a max term. So in case of the sum of product, the every variable can be represented as a like a, b, c, second way a bar, b bar, c bar. That means this is an ordinary variable, this is a complement variable. The ordinary variable that can be represented as a high logic, and it is known as a logic 1. And complements, this is known as a low logic, and it is known as a logic 0. Here is exactly reverse of this SOP form. Here is also we have to represent the variable like either a, b, c, otherwise a bar, b bar, c bar. This a, b, c is represented as a low logic, and this is represented as a high logic. This means low logic is represented as a logic 0, and high logic means it can be represented as a logic 1. Another difference of sum of product and product of sum, the representation of the any mathematical function in the form of SOP form, that can be represented as a sigma small m, while in case of the POS, that can be represented of any mathematical function as a pi capital M, right? So whenever we can simplify of any logical expression in terms of the SOP form, at the time we can simplify with the A, B, C logic, and each and every logic can be represented in terms of the product, and finally result of every product we have to take the addition. In case of the POS, this is the reverse form. Every variable result can be represented as a addition form, and a final we take the product of each and every addition. This is the basic four difference in terms of the two different method of Carnot map method, right? First one is each and every terms can be represented as a min terms, while in case of the POS each and every term can be represented as a max term. The second difference is this is a high logic A, B, C, and it can be represented as a logic 1. Here the ordinary variable A, B, C, that can be represented as a low logic, and it can be represented as a logic 0. While complements of each and every variable, this is A bar, B bar and C bar, that can be represented as a low logic and indicate with the logic 0, right? And in case of the POS, this is a complement of any variable is like A bar, B bar, C bar, that can be represented as a high logic, and this can be represented as a logic 1. And the representation of SOP form in K-map method, that can be represented by a sigma small m, while in case of the POS form, that can be represented as a capital pi capital M, right? So now we can discuss about that 2 variable, 3 variable, 4 variable and 5 variable K-map structure, right? So first one is a 2 variable K-map structure. K-map structure. And right now we have to discuss about the each and every structure in the form of the SOP, sum of product, right? Then after complete this every 2 variable, 3 variable, 4 variable and 5 variable structure in SOP form, then we can discuss about the POS form. Now how many variables are given? 2 variable, right? So possible combination of 2 variable, this is the 2 raised to 2. So we are getting the 4 possible, right? So we have to represent the every variables. This is the basic structure. So number of cell are in 2 variable structures are 4, right? And the 2 variable can be represented as A and B, right? So here is the 0, here is the 1, here is the 0, here is the 1, right? This value can be indicate the value of A, right? Means here A is 0, that can be indicated with the A bar, and here is the A is 1, means it can be indicated with the A, because of we can represent this structure in SOP form. Similar way, this is the value of B, so that can be represented with the B bar, because of B is 0, and this is the B. So here this is the 0, 0, A is 0, B is also 0. In this cell, this is the value of A is 0, but value of B is 1. In this cell, value of A is 1, B is 0, and last one is both are the 1, 1. Right? This is the address of each and every cell. Otherwise, how we represent another way of address? In this lecture, we have to discuss about the SOP form can be represented as a sigma small m. So this cell is M0, this is the M1, this is the M2, and this is the M3, right? So in case of the SOP, we can represent the address of each and every cell. This is the first cell. So address is, this is the here is the A bar, and the value of B is also B bar. In this cell, the value of A is 0, this is the A bar, and value of B is B. In this cell, the value of A is 1, so A and multiply with B. B means B value is 0, so it is a B bar. And last cell, A is also 1 and B is also 1. So this A dot B. Because of this term can be represented as a sum of product. Every variable we are considering the product. Right? So this is the 2 variable K-map structure. Now we can discuss about the 3 variable K-map structures. Three variables K-map structure. In SOP form. Right? So number of variable are given is 3. So we have to consider the total possibility of this variable is 2 raised to 3. So 8. Right? So we can represent the 3 variable K-map structure. Our number of cell are 8. So now we can design the 3 variable K-map structure. Suppose that 3 variable can be represented as A, B and C. Right? So this is the A and this is the B and C. So first one is A is either 0 or a 1. Here is either 0, 0, 0, 1, 1, 1 and 1, 0. Right? This value can be indicate the value of A. Here the first digit that can be indicate the value of variable B, and the second digit that can be indicate the value of variable C. Right? Now one question is arise that in first column we have to represent the address 0, 0, then 0, 1, and now we have to return the 1, 1. Why we cannot return the 1, 0? And last column we have to return 1, 0. So this K-map is reflective structure. So whenever we can shift it from one row to the second row or a one row to the one column to the next column. Right? So only single variable are the difference. This is the characteristic of the K-map. I again repeat this characteristic. Whenever we can shift it from the any row to the next row or any column to the next column at the time, we can shift it the only the single variables. So if I can replace the, here is the 1, 0. So here is the 0. So the now B is here is 1, right? So 1 bit is difference, and the value of C is here is 1. So here is 0. Both bit are different. Now if we have to represent the 1, 1. So B is here is B is 0 and here is B is 1. So one variable will be different, and the second variable C is 1 and here is also 1. That's why we have to return that here is the 1, 1 and last column we have to return the 1, 0. Right? This is the characteristic of K-map. Now we can represent the address of each and every cell. Here value of A is 0 and this in this cell B and C is also 0. This is the 0, 0. Now here is the A is 0 and B is 0, C is 1. In this row A is always 0 and B is 1, C is also 1, and A is 0, B is 1, C is 0. Here A is 1, B is 0 and C is 0. A is 1, B is 0, C is 1. A is 1, B is 1 and C is 1. And last one is A is 1, B is 1 and C is 1. C is 0, right? This is the address and it is given into terms of the octal. Now in terms of the binary, now we can convert these binary terms in terms of the octal, right? So this is the equivalent value of 0, and SOP form we can represent as a small m, m0. Here this is the value of m1, this is the value of m3, not m2, right? This is the value of m2. Now this is the value of m4, this is the value of m5, this is the value of m7, not m6, and this is the value of m6, right? Now we can represent the address of each and every cell this is the M0. A value of A is 0, B is 0 and C is 0. So this is the A bar, B bar and C bar. Right? Now in this cell A is 0, B is 0 and C is 1. So that A bar dot B bar dot C, because of C is 1. In this cell 0, 1, 1. So this is the A bar dot B dot C. This is the A bar dot B dot C bar. Here this is the A is 1. So A, B bar, C bar. Here is A, B bar, C. Here is A, B and C. Here is A dot B dot C bar. Right? So this is the address of each and every cell of 3 variable KMF in the form of SOP, sum of product. Right? Now we can discuss about the 4 variable KMF in SOP form. Four variable KMF structure in SOP form. Right? So 4 variable are given that, so number of cell, this is the 2 raised to 4 means 16. Right? So we have to use the 4 variable A, B, C and D. So number of cell are 16. So that number of cell are 16s, right? So this one can be represented with the 4 different variable A, B, C and D. So in this column we have to consider the 2 variable A, B, and in row we have to consider the next 2 variable C and D. So this value can be indicate the value of A and B. This one is first cell 0, 0, then 0, 1, 1, 1 and 1, 0, right? So first bit that can be indicate the value of variable A, and the second bit that can be indicate the value of variable B. Similar way here is 0, 0, 0, 1, 1, 1 and 1, 0, right? So now we can defining the address of each and every cell in SOP form. Here is 0, 0, 0 and 0. Here is this row is always 0, 0, AB. 0, 0 and this one is column 0 and 1. Here is 0, 0, C and D both are the 1, 1. Here is AB 0, 0 and 1, 0. This one is 0, 1, 0, 0. 0, 1, again 0, 1. 0, 1 and 1, 1. 0, 1 and then 1, 0. 1, 1 and 0, 0. 1, 1, 0, 1. 1, 1, 1, 1. 1, 1, 1 and 1, 0. Right? Here is the 1, 0. So 1, 0, 0, 0. Here is 1, 0, 0, 1. Here is 1, 0, 1, 1. Here is 1, 0, 1, 0. This is the address of each and every cell of 4 variable KMap. Right? So now we can represent in terms of the SOP. So it can be represented as a small m. So here we have to represent the each and every address of group of 4 bit of binary. Now we can find the equivalent value in terms of the hexadecimal. So this is the 0, 0, 0. So it can be indicate the value of hexadecimal is also 0. So the address is also represented as a M0. This is the value of 1. So it can be represented as a M1. This is the value of 3, not 2, right? So this cell can be indicate the M2 and this is the M3, right? Similar way, this is the M4, M5, this is the M6, This is the M7. Now we have to consider the next row. M8, M9, M10, M11, then M12, M13, M4, M15, and this is the M14, right? So now we can defining the address of each and every cell. Here is the all are the 0, 0, so it can be represented as A bar dot B bar dot C bar dot D bar, right? Here is the value of D is 1 and the remaining 3 variables are 0. So this is the A bar, B bar, C bar dot D. Here A, B are 0 but C and D are 1, 1. So A bar, B bar dot C dot D. Here is A bar, B bar, C, D bar. Here A bar, B, C bar, D bar. Here is A bar, B, C bar, D. Here is A bar, B, C and D. Here is A bar, B, C and D bar. Here is A, B, C bar, D bar. Here is A, B, C, D, C 0, so C bar. Here is A, B, C and D. Here is A, B, C and D 0. This is the D bar. Here is A is only 1. Remaining 3 are 0. So B bar, C bar and D bar. Here is A, B bar, C bar, D. Here is A, B bar, C, D. And last one is A, B bar, C and D bar. This is the address of each and every cell of 4 variable K-map, right? Now we can discuss about the 5 variable K-map structure. In SOP form, 5 variable K-map structure. 5 variable K-map structure in SOP form. Right? So dear students, in 5 variable means number of possibility are 2 raised to 5. So we are getting the 32 cell. Right? So in case of the 32 cell, it can be also defined as a 16 plus 16. And 16th number of cell, that means it can be indicated with the 4 variable K-map. And the next 16 is again, this is a 4 variable K-map. So 5 variable K-map structure, that is a combination of 2 4 variable structure, right? So 5 variable can be represented as A, B, C, D and E. Now first variable, we have to difference in the both the cell, right? And the remaining 4 variable B, C, D and A. This is the 4 variable K-map structure. In first 4 variable K-map structure, we have to return the 5th variable. A is 0 and in this K-map structure, next 4 variable K-map structure, we have to represent the 5th variable as a 1, right? Now we have to draw the structure of 5 variable K-map. So this total number of cell are 16 and this is also total number of cell are 16 and total combination of 16 plus 16. So we are getting the number of cell are 32, right? So this is the first 4 variable K-map structure. So in each and every cell we can represent the value of first variable A equal to 0, and this is the next 4 variable K-map structure. So we can represent the 5th variable is A equal to 1. Right, each and every cell for this variable structure. Now the remaining 4 variable structure, this is a similar structure of 4 variable K-map structure. So can be represented as this is a B, C and this is a D and D. Here is also B, C, and this is a D and E. 0, 0, 0, 1, 1, 1, and 1, 0. This is the 0, 0, 0, 1, 1, 1, and 1, 0. 0, 0, 0, 1, 1, 1, and 1, 0. This is the 0, 0, 0, 1, 1, 1, and 1, 0. Right? So, in this first 4 variable K-map structure, we can represent the first 16 bit. First 16 means 0 to 15. And the next 4 variable K-map structure, we can represent the next 16 bit. This is a 61 to 31. Right? So, in this cell, this is the address is 0, 0, 0, 1. Sorry, 0. Here is 0, 0, 0, 1. Here 0, 0, 1, 1. Here 0, 0, 1, 0. Here is the address 0, 1, 0, 0. 0, 1, 0, 1. 0, 1, 1. 0, 1, 1, 0. Here is the address 1, 1, 0, 0. 1, 1, 0, 1. 4 times 1. 1, 1, 1, 0. This is the 1, 0, 0. 1, 0, 0, 1. 1, 0, 1, 1. 1, 0, 1, 0. Right? Now in this 4 variable K-map structure, again address will be always same. Here is the 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1. Here is 0, 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 1, then 1, 1, 0, 1, 0, 0, 1, 0, 0, 1, 1, 0, 1, 1, and last one is 1, 0, 1, 0. Right? So, in this 4 variable K-map structure, we can conclude that each and every cell of equal position, for example, there we have to consider this cell and here we have to consider this cell. Both the cell, the address are same for the 4 variable B, C, D, E. That means we can overlap the 2 structure. This is the lower plate of 4 variable K-map structure, and this structure can be always superimposed to that first 4 variable K-map. Because of the address of each and every variable will be same. The only difference are there. This is the difference of the first variable. In this lower plate, we have to consider the value of A is 0, and this plate we have to consider the A is 1. Right? So we are getting the same position of each and every cell. Like for example, we have to consider this cell. So equivalent to this cell is here is that. Right? So here is the B, C, D, E, all are the ones. Here is also B, C, D, all are the ones, right? But in this case, this cell we have to consider the first variable A equal to 0, and in this cell we have to consider the A equal to 1, right? So this the characteristic of 5 variable K-map structure. This is the first 4 variable K-map structure can be superimposed to that next 4 variable K-map structure, right? Now we can defining this address. In terms of the SOP, this is the M0, M1, M2, sorry, M3. This is the M2. M4, M5, M6, M7, M8, M9, M10, M11, sorry, M11, this is an M10, M12, M13, M14, M15. Here is M16, M17, because here now we consider the first variable A equal to 1. M17, this is the M18, M19, M20, M21, M22, M23, M24, M25, M26, 27. M28, M29, M30, and this is the last M31. Right? So this is the address of each and every variable of cell. Now we can represent the address of the 5 variable. So this is the, here is the A is 0, and the B is 0, C is 0, D is 0, and also 0. So the address is A bar, B bar, C bar, D bar, E bar. Here A is 0, then B is 0, A bar, B bar, C bar, D bar and E. Here this is the A bar, B bar, C bar, D and E. Here A bar, B bar, C bar, D and E, right? So here the address of this one is A bar, B bar, C, D bar and E bar. Here is A bar, B bar, C, D bar and E. Here A bar, B bar, C, D and E. Here A bar, B, C, B bar, C, D and E bar. Like that, right? So we can represent the each and every value of address. Similar way, here we have to represent the address of this cell is, here A is 1. So this is the A bar, B is also, A, B also 1, C also 1, D is also 1, B, C, D and E is 0. So this is the E bar. Here A is also 1, B is 0, B bar, C 1, D 1 and E is 0. That can be indicated with the E bar. Here A is 1, B, C 0. So B bar, C bar, D and E bar, right? So this is the address can be represented for this cell. We have to A value of A is A1. So this is the A, B is also 1, B bar, C is 0, C bar, D 1 and E is also 0. So this is the address can be represented in the 5 variable K-map structures, right? So dear students, now in next video lecture we can discuss about the example of each and every K-map structure. That means 2 variable K-map structure, 3 variable K-map structure, 4 variable K-map structure and 5 variable K-map structure in SOP form only. Then we can discuss about the POS form. Thank you.